So today's agenda is very straightforward. I'm in the introduction part. I'm happy to introduce our topic for today, SAGE3, AI in the next generation of remote collaboration. Our presenters are really close and colleagues for many years. Jason Leigh, who's a professor of information and computer science and director of the Lava Lab at the University of Hawaii in Manoa, and Luc Renambot, who's a research associate professor, Department of Computer Science in the Electronic Visualization Lab at the University of Illinois in Chicago. They're going to talk to us about what they've been cooking during the pandemic. And so I'm going to yield the remainder of my time to my honorable colleague, Jason Leigh. Jason, take it away.
Okay, let me share my screen. Make this big so I can see everyone's faces.
And I'm hoping that we can spotlight Jason's video.
Oh, I guess I can do that too.
There you go.
So this project, SAGE3, is a collaboration between University of Hawaii, University of Illinois, Chicago, and then our most recent partner has been in Virginia Tech, who are experts in human-computer interaction. And I'll elaborate on that in a moment. Let's run through. Just a quick introduction to the folks involved. It does take a pretty decent amount of effort to actually develop software like SAGE3. But actually, even before that, let me explain what SAGE3 is in a nutshell. So some of you may have heard of SAGE and SAGE2, and now we're at SAGE3. Basically, it's software to allow people to work collaboratively on large display walls. And since the pandemic, a lot of interesting things have happened that's motivated the evolution of SAGE3, which we're going to show you today. So we're going to spend just the beginning of the time period talking about what it is and what it can do, but really the proof is in the pudding, and we're actually going to give you a live demonstration. The demonstration that we did yesterday involved both Hawaii and Chicago, but I decided to give my Hawaii kids a bit of a break because it would have been like 5 a.m. in the morning to get to the lab and set up for that. So I thought I'll let them sleep. And so Luke is going to be the Chicago end for the live demonstration. So there's myself, Maddie Belcade, and Ryan Thirio in Hawaii. Maddie Belcade is the bona fide artificial intelligence expert. And then in Chicago, we have Andy Johnson, my very close colleague from Chicago, and then Maxine Brown, of course, whom you all know very well. And then Luc Renambot, who's been really at the beginning of SAGE since the day one. So he's the sage of SAGE, so to speak. Our newest collaborator is Chris North from Virginia Tech. Chris and I have known each other for some time now, primarily because Chris has done, he's probably the world's leader in understanding how people work in large display environments, and it's the benefits of the technology. And so I always tend to cite his papers when I write grants to build the new versions of SAGE. It's been a really cool synergistic opportunity. Okay, so of course, students really are the ones that do most of this work. And so Nurit Kirschenbaum in Hawaii is a user interface designer. Dylan Kobayashi, who's just graduating, is our SAGE advisor, so he can focus on his PhD. And then we have new students coming in, Roderick Kabalba, who's our developer. And then in Chicago, we have Andrew Burks, Krishna, and a few undergraduates, all helping out in this huge effort. And then in Virginia, we have Jesse Harden, who does a lot of HCI and ethnographic studies of how people work in front of display walls, how people would like to use display walls into the future. So where we are today is that since SAGE began in 2004, we're about 17 countries with 4,000 users and 800 sites. And more we're seeing sites building not just one tile display, but multiples. For example, when I moved to Hawaii, I started with one display in my lab. We're at 18 displays in Hawaii. connecting all the universities and various research labs together. And as then, this is a lot of you actually use SAGE, so you know that you tend to use it in a lot of applications, everything from archaeology to art to statistics to science of all varieties. So I don't have to elaborate too much on that. So just a bit of fun history. Tom remembers this too, because this was way back when we first built the tile display in Chicago. So in 2004 was when SAGE was officially born, all C++ code base back then. And in 2004 was also when Facebook was first born too, just sort of dating how far back the stuff was. And it took $500,000 to $1 million computers to drive SAGE. It required a compute cluster. And grid computing was the technology of the day. And as you can see on the right, that's what our SAGE walls look like. The borders were about 1 inch thick. I don't know how we lived in those days, but we did. Fast forward about a decade later, we're able to develop SAGE2 and drive these things not on a cluster anymore, but a single PC. And the display technologies have also gotten cheaper to the point that we can build pretty cool displays for 100K to 300K. And then the technologies that we were leveraging were things like science portals, gateways, and cloud computing. At that time, JavaScript frameworks really was just starting to emerge. And so a lot of the code that we had to write were completely 100% from scratch. And the only thing notable I found in 2014 was the ALS water bucket challenge, ice bucket challenge. So I don't know if anyone remembers that event. But in 2020, fast forward to 2020, when we got the NSF award for SAGE3, this basically funds us for the next 5 years. We are now in SAGE3 able to drive systems using single PCs, a laptop, and all the way up to low-end visualization systems that are about $100,000. And then today, the key technologies that we have to connect to are data science notebooks, cloud AI, container, and then NSF's cyber ecosystem. So when the pandemic started, what I did at home, probably like a lot of other people, is that I went to Best Buy and I picked up two 40-inch TVs. They're 4K TVs, and I'm actually using them right now at home, right? And that became my SAGE wall. And each TV was $240, right? That's insane. For $500, I had a SAGE wall at home. And we would never have dreamed of that 10 years ago. Okay, anyway. Couple of things are important about SAGE3, and then we'll probably jump more into the demo. We re-architected SAGE2 from the ground up. There is nothing of SAGE2 left. It's a complete clean rewrite. We can now take advantage of all the new JavaScript infrastructure out there. We're using React, Redis, and all these other cool new emerging tools. We redesigned the whole user interface for this post-pandemic reality. No one can go back into the lab, so you sit in front of display walls next to each other. So we re-architected SAGE3 so that now you can actually work on your laptop, looking at all the content on a SAGE wall as clearly as you can see in your lab sitting in front of a display wall. So that means that for the first time, people who are traveling can still get into a SAGE meeting, look at all this content. And we're going to demonstrate that. So I'm the one at home, and Luke is the one in the lab, and we're going to demonstrate that live for you in a moment. And then the other components is CineGrid is about artificial intelligence this year. A major thrust in the next 4 years of SAGE3 will be to focus on using artificial intelligence. And what I mean by that is two things. One of the things is enhancing the user interface with artificial intelligence, making it a first-class partner in a collaboration. The amount of content that you can put in the SAGE wall, it's starting to get pretty big, and it's really tedious for people to move stuff around to organize their ideas, their thoughts, and the discussion. We want to use AI to help see the connections between information, to do some automatic organization of content on the walls. Or if you're working on a specific task, there are AI-enhanced templates that will help you get that job done. The second thing is, since we're primarily funded by the National Science Foundation, we're here to serve scientists and make them be more competitive in America, against our foreign competitors and all that good stuff, the usual stuff. And so what we're trying to do is take a lot of artificial intelligence capabilities that are hard for them to use because they're not computer scientists, and integrate it into the SAGE environment so that they can do their scientific research, take data, throw it on the SAGE wall, and have AI figure out what's the right algorithm to use to do their analysis, to get their discoveries done faster. So that's SAGE3 in a nutshell. Just a fun little chart to show you the difference between using a big display wall like SAGE2 and using a PowerPoint projector in the classical boardroom meeting. With when you're in a boardroom, you got a projector. In Europe, it's called a beamer, and you have a cable. You plug it into your laptop, and then you pass that cable around, right? Or at most, you have Apple TV, right? And then Zoom. So what we did was we did a little survey with our students of what they feel it was like to work in front of SAGE. What was it like to then switch to having to go back to a PowerPoint projector mode of work? And then finally, when the pandemic hit, we asked them to compare what's like to be in a meeting in Zoom. So these are the kinds of questions that you see, right? Basically, how focused were you in the meeting? How much did you feel you contributed content to the meeting? How easy was it to contribute content to a meeting? How actively were you participating in meeting? I'll share these slides later, and you can look at the data in closer detail. But what we saw was people with SAGE were far more, they agreed more that SAGE actually helped them maintain focus, contribute more to meetings than the PowerPoint mode, which is basically, one cable at a time. That's my neighbor's dog, sorry. Interestingly, Zoom wasn't that different from the PowerPoint projection model. So that kind of opened the door for us, saying, well, if we could somehow provide SAGE's capability in this Zoom pandemic world, we may have something that is actually valuable to more than scientists, but people who are actually working with information. So anyway, enough of that. I'm going to skip this slide for now. We'll come back to it later. And let's do a live demo. So what you're seeing in my PowerPoint presentation actually wasn't PowerPoint. I'm doing this in SAGE. So I'm going to zoom out. And actually, you can see this is my SAGE environment. There are a couple of pointers here. You've got Chris from Virginia Tech here, and Ryan he's also up, I guess, from Hawaii. This is Chicago wall, and this is Andy, and this is Dylan. All right, I can pull this out. This is my little radar view. See the pointers flying around, and this is the slide presentation I had up here, which I can move around. So now I'm going to stop sharing, and I'm also going to show you on the Chicago side what it looks like. So now, if you look on your video screen here or here, I don't know, depends where Zoom put me. That's the view from the Chicago display wall.
Everyone, you have to shift your Zoom window to speaker view, please, so that you'll see Jason's side-by-side windows. Thank you.
Okay. Thanks, Laura. So if you can see this, I can, move stuff around. I can move this presentation I had around, and it moves on Luke's wall, right? Okay, big deal. I can change the slides remotely, and I get to see all my slides in perfect detail, and so does Luke. And Luke also, he's in front of his touchscreen. Somebody else grabbed that from Luke and took it away from him. So anyway, okay, so we're up on SAGE. So some of the things that I can do, like the previous SAGE, I'm going to share back my screen so you can see what I'm doing. right? Some of the things I can do is I can go to my very messy folder and bring out the CineGrid demo folder, and I'm going to just throw some content up there. I'm going to throw up a fun little movie file I had. Okay, well, we'll just use the, oh, here we go. This one's a fun one. Upload that, and then I'm going to throw in the PDF file while I'm at it. And I'm going to throw in some static pictures, throw that in there too. Okay. And it's loading right now, I believe. And by the way, this is very, very pre-alpha. So who knows, it may crash. So we've loaded some stuff here and you can see it loading up. I'm going to zoom in. So this is one of the old CineGrid pictures we took. We'll give you a prize if you can guess what year that was. I actually don't know. I thought maybe one of you know.
It's 2007.
It
Really?
looks like all the usual suspects.
And so you can see the contents loaded. This is a PDF. I can make it a little bit bigger. And tell you what, I'm going to tell Chicago, hey, why don't you make that a multi-page PDF so we can see it open up across your wall?
Okay. I can just press a few keys up for me. Yes. And resize it. And so now we can look at the same PDF and point at the content, at the first pictures, for instance, the ACM logo and big tile display and things like that. So we can look at the same content and or discuss it and look at the same thing.
And then just above the PDF, we have a little movie file. I can just press play on it. It's playing. The sound is automatically muted, but if I turn it on, it may blast your ears. I'm not sure. Okay, but I think you heard something, right? It's a fun little cool video game that just came out called Agent Intercept, which is a whole lot of fun. But as you can see, this is like the old Sage. We're moving stuff around, we're throwing content up so we can have a meeting. But the important difference is I can do this from home. We could never have done this from home 5 years ago.
So Jason, I just want to confirm the shared screen window that we're seeing is your laptop in Hawaii, and
Correct.
the spotlighted big wall that we're seeing is Luke in Chicago.
Correct.
And you put up a PDF screen and Luke in Chicago manipulated it and it appeared on your laptop that we're seeing on the Zoom window, right?
That is correct.
At the same time as we saw it change in Chicago.
Yes. So you look closely at the video in Chicago, it's roughly in sync with my video on my laptop. It's hard to tell when you look at it. So, but let me back out even further. You can actually see, I'm going to make this window a little smaller. This is Sage running on my laptop. This is just my regular laptop, right? And so I'm going to switch over to Luke.
What is the configuration? You mean your regular laptop?
This is what I mean by my regular laptop. This is my home laptop. Because
He asks, what is the laptop?
Oh, the laptop is an Apple, 1-year-old Apple laptop.
RAM and
I have
core number?
I have like 32 gigs, maybe 8 core, 4 terabytes of storage.
All right.
And it doesn't need that capability, but
Okay.
you know, computer scientists, we like big toys. Okay, so let me stop sharing and I'm gonna have you focus on Luke's window.
Let's see. Yeah. Okay, so you should be able to see the wall in Chicago. So if you use SAGE2, it's just a little bit, we have a lot of commonalities, but it's also a little bit different in the sense that, so now we are in this shared workspace. that if I move a window locally in Chicago, everybody sees that window moving everywhere. But at the same time, we keep the local view and scale is private to your wall, so you can adapt it to whatever display. And that's the part that makes it work. Like that, Jason can see it on his laptop, and we can see it on a big wall. And yesterday we had the wall also in Jason's lab, so we could have multiple walls and multiple laptops all at the same time. So you can see here in the overview video stream, you can see I'm manipulating the wall, so I can make it very small, very large, and I can very easily switch between application. And when I select an application, it just makes it full screen locally on my wall. It's not changing the position and scale, it's just changing my viewport onto this kind of canvas that we have there. So I can switch application. And for example, here I went back to the JSON slides, and that's what you saw during the presentation. In fact, you might have seen Pointer flying by a little bit during his presentation, but that's what happened. And I have a button also where I can just click and see all the windows open at once. So for instance here, so we have a PDF, we have video, we have sticky notes, very common for brainstorming. We use that a lot. And it works in a way where if you have text in your clipboard, you can just paste the text and we create a quick note from that, from your clipboard. So we have images, PDF, and another very important part that people used a lot in SAGE2 was the web browser, or the web view that we were calling it. So we can, again, bring web content directly into the wall and open as many of them as we want. So let's see, first I have a URL here, and I should be able to paste.
Make sure you zoom in so that folks here can see, because the camera tends to blow out with the wall.
Zoom the physical camera in, Luke.
Mm-hmm. And I can see the video a little bit.
Yeah, so you can ask Luke or Lance or Andy to help.
And so first on here we're looking at the web page, and everybody in the session will see that web page and look at the same thing. For instance, here's the story about Jason's lab, and so we can. And again, it brings that you can bring almost any content you want available online and display it into the wall. Let's see. Another part that, so since we are focusing on data science, we made a notebook viewer that you can basically just drag and drop a notebook onto the wall, and we can all look at that notebook. And for now, it's still not like a live notebook. It's not interactive, but at least we can visualize the notebook, and that would be the next step. We want to make those notebooks live and connected to cyber infrastructure, so we can leverage things like the Nautilus environment, for instance, and leverage all kind of resources online and do data science directly onto the wall and share the content. So you should be able to see I'm scrolling right now through the notebook, and we can all look at it. And since it's a fairly big wall that I have in front of me, I can change the layout of the notebook, and that's something we are looking at, and that Chris in Virginia Tech has been looking at for a while too. Now is how do we display those notebooks in very large, when we have a lot of space, basically. And so here it's just a 2D grid, but so we are exploring on maybe how to deconstruct the notebook and show it differently and let people interact with them differently. So that's one. Another application. Let's make it smaller so we can see what else. So we have we've been working on a drawing application. Not completely because we want a drawing application, but it's a very interesting application because now we have multiple users interacting with the content or generating content and strokes, so we can all draw on the board. And so that's very useful to test synchronization and track who is doing what onto the wall. And like before, I can download the content and can undo some of my drawing. I cannot undo somebody else's drawing, and so that's a nice application to test all those really nitty-gritty protocol in the backend to synchronize the data. And at the same time, drawing a whiteboard is always useful for in a meeting. Let's see. So we have an image viewer. So we have, of course, we need the default map application. Always, we want to show geodata. We have a student working in Hawaii, looking at loading GeoJSON layers, for instance, into those maps and leverage again the resolution and the scale of those displays. So I can move to the map, and you should see that it's synchronized across all the location. I can change the setting of the map, and everybody will see something the same thing. And I can again, all the pointers are also synchronized across all the applications. So if somebody point at for instance, at the coast or the harbor in Hawaii and stuff like that, so we know we are pointing at the same thing. Here, for instance, Jason and Andy are pointing a different part of the map, but we know that when they're pointing at something, they're pointing exactly at the same location, so we can engage in a discussion and know for sure that we are talking about the same aspect of the data. Let's see what there's so sticky note web browser, and so we're also working a bit like in SAGE3, integrating all kind of various APIs. So for instance, for data visualization, here's just a trivial example, but we're looking at Plotly and VegaLite, and so you can integrate all your usual data science libraries like D3 and Plotly and Vega and what else comes this week. There's always something new and interesting to do data science, and even machine learning in the browser is getting more and more popular. So keeping that JavaScript kind of philosophy or environment, let us again bring all kind of library and functionalities that hopefully the community would participate at some point into it. And then the next big project in SAGE3 would be the integration of let's say the real, between quote, data science done in Python and done on various infrastructures. So it could be done on your laptop, but it might be done on a supercomputer and something like that. So that's where Jason's collaborator in Hawaii in AI are bringing their expertise to see how we can combine powerful AI backend into the environment to do simple things first, like even just maybe helping about the layout of the content, but also continuously looking at the content, saying you have 5 PDF on the wall, and you might be able to synthesize a topic summary about what you are looking, or suggesting new publication and stuff like that, or looking at video and labeling interesting part in the video, or for instance, looking at that CineGrid picture and maybe labeling all the people in that picture, or telling us when it was taken. I'm sure there's some software that would be able to tell us when it was taken, something like that. So that's where I think there is a really interesting work is going to start this summer, is when we start integrating the AI part and the smart workflow and smart workspaces. Let's see, do we have something else? And maybe the last one that I can try to share is an application that was very powerful also for and used a lot in SAGE2 was a screen sharing. So we'll try to share my screen. So it opens a window on the.
And Luke, I'm sorry to interrupt. I see a laptop in your lab at the lower right of the video frame. Can somebody scoot it forward and to the left, despite what I wrote, so we can see it as you do this trick?
Let's see, and the screen sharing is something we just added recently. So let's see if we can make it work. I don't know if it's going to work. Oh yeah, it is working. So you can see on Andy's laptop, you can see my screen. And again, it's the scenario where you don't want to share the data, or you don't want to share the file, but you have something that you want to show on your laptop, and I can go to any website or use any application available on my laptop and display something. So for instance, I can go to the Jupyter website, and so we can all discuss about the Jupyter software, for instance, things like that. So here, again, there is always this separation between what you want to share on the wall and what you want to keep private on your laptop. And that depends very much on what you are doing. If you're just in education or if you're in a company, that might be very, very different, or you're in a national lab or something like that. So, and again, it's screen sharing without any plugin or application, or it's just built in into the system. Yeah.
And so, and I can, just so that folks at home can sort of see more clearly, if I hit the share screen again, you're going to see basically what I'm seeing from home. And as you can see from home, instead of that blurry zoom picture of the wall, I have a very crisp view of all the content on the wall. Assuming Zoom does its job.
Yeah, we're seeing it here.
So I can continue to play this video.
Mm-hmm.
And this video is actually live streamed from Sage.
Chicago.
From Chicago, actually, yes. Even more impressive.
So like
so I can really work from home even without a display wall.
So in stage 2, the content was sort of uploaded to a local folder and then played from there. Here, it's all streaming.
Yes, it's pretty much all streaming.
I mean, in the sense of HTTP streaming, not really like it's not Netflix yet, but it's
yeah, it's not Netflix yet, but that's the next step, right?
Well, just to be clear, Jason, what we talked about yesterday is we're watching Zoom stream the screen of your laptop, which is shared with Luke, and yes, inside your laptop, you're streaming a video that's located, I don't know where.
In Chicago.
Right. So we're streaming, sharing shared stuff.
That's
so
correct.
A combination of Sage plus a video app like Zoom or Teams or WebEx is really powerful.
Yeah. And so we can certainly, there's some video conferencing tools like Whereby that we can also embed directly into the Sage environment. But so many people are using Zoom these days, we thought, well, let's not go against the competition. Let's sort of work complementarily with Zoom. So people can still use Zoom, but if they want to get work done, they will go to Sage, right? So they can see a whole bunch of documents and fly through them, create giant storyboards, create giant post-it walls that's persistent that they can jump to at any time. And in fact, one of the things I want to show you is that this is just one room, one board. If I were to leave this room, I have some other boards that we created, right? So I can go to my surfboard where I have, surf data for the day. So I can look at the surf conditions. This is a view from Waikiki. It looks kind of flat. Doesn't look like I want to go out today, right? This is from Monterey Aquarium, actually, to play. So you can imagine having all these different boards for all these different meetings or different projects, right? You have a brainstorming meeting, and you have everything all prepped, or you have a storyboard meeting, you have all this stuff also all prepped, and you can just jump to any of these boards at any time and change stuff, look at stuff. Over time, we'll probably add permissions, so you can, restrict what people can do in some of these boards. Like maybe you can only look at stuff, maybe you can edit stuff, right? So anyway, yeah, let me go back to this one. And I just want to quickly finish up a little bit with some of the more sciencey bits, because again, we're funded by National Science Foundation to help scientists. So I got to get this stuff in. I saw a thing from Kevin Thompson from NSF, so I should say, let me say that. So one of our partners at Virginia Tech, they did some extensive surveys of the scientific community to look at what are the data science type use cases or tools that they use. We are using this basically to motivate a lot of the future direction of the work that we're doing in SAGE3. And from what we can tell, in a nutshell, without going into details with these charts, Chris North, by the way, is the person in charge of this, and he's actually here too. So feel free to ask him follow-up questions. You know, Jupyter Notebook seems to be the dominator in this space, but for scientific notebooks. But as far as the tools are concerned, it's really spread, you know, pretty broadly across everything from Excel to Jupyter Notebooks. So those are the kind of things we have to keep in mind as we continue to develop SAGE3 for our end users. And to be really, really bold and stand on the limb, I would argue that, you know, the thing about Jupyter Notebooks is that it's a completely linear notebook. Whereas the way people work in these scientific exploration, it's actually not so linear. They want to tear the notebooks apart. Well, SAGE actually will can provide them with that ability to do something like that. And we're exploring a whole bunch of different modalities for supporting that. So to go out on a limb, I'd say we can potentially be the Jupyter killer. Hope there are no Jupyter people out there. It'll be a big fight. So anyway, that's pretty much everything I wanted to cover today. There's only, Lauren, do I want to go for one last
Go
thing?
for it. Go for it.
Okay. So Lauren and I were discussing whether I should show this or not. And actually somebody asked this question in the last session. So we do have one more thing, you know, channeling Steve Jobs now. And somebody asked, well, what about virtual reality? Yes, we have a prototype. And I'll show you the prototype. And then I'm going to flash this light at you, so it'll make you forget all the intellectual property. So this is a very rough video. By the way, this wasn't done for demo purposes. This was just a capture that we did just for research presentation. We developed essentially a connection to SAGE2. This is the older SAGE. This work was done about 1.5 years, 2 years ago, where in virtual reality, in a virtual space, you can stand in front of any number of big display walls as if you're actually physically in front of them. And these big display walls can be anywhere in the world. And the nice thing about that is that now you have the entire virtual world to place all this information, not just your small laptop, not just your small, you know, in the confines of your home. So I'm going to play this video and you can watch just a snippet of what it looks like in VR. So you see some content. This is actually the old SAGE user interface where you can see content on the wall. That's some remote wall that Dylan, my student, is connecting to. This is the little control panel he's using. You can bring up additional copies of the notes, move things around. I'm just going to pause there. We didn't prepare a cool, sexy video for this, so it's just a kind of a teaser. And interestingly enough, what we see is Microsoft working on the HoloLens, and also Facebook also starting to do this work. Again, they're in the same way responding to this post-pandemic reality where people are opting to work at home. How can they use virtual reality to create spaces where people can still see each other, work inside these completely immersive offices of information? And so that was our little experiment in what we called SAGE XR. XR is extended reality. And I think that's it. We can open things up for questions.
Thank you very much, Jason. And if we can, people, I think Jeff has the prerogative, droit de seigneur, of the first question.
Oh, well, thank you, Lauren. Yeah, I do have a question, and it didn't come up yesterday. But what's your approach to application security? Do you encrypt? Can you encrypt the connections? Let's say, for instance, you have two people working on highly sensitive or proprietary projects. Is there a way for them to secure the transmission between the sites?
Right now, all the communication are done over HTTPS, so that's the minimum we've done. So it is encrypted, but it's a regular SSL encryption from the web, basically. So and we are working on login protocol. So like right now, anybody, let's say people are not authenticated right now, but it's almost there. So we are getting ready this summer to have that fully worked out with permissions and stuff like that. But for the encryption, yeah, it's encrypted WebSocket and encrypted HTTP. So yeah, standard stuff.
And there have been a number of questions, Jason, about the how quickly people can get access to beta code, or how you're going to open this up, or how can they get in the sandbox and play with you?
Yeah, so we're planning for a really broad release of the beta code in November for people who want to play with it. At that time, we also want to put some notion of the artificial intelligence in it, just so that people can see the impact of AI in these kinds of environments. You notice we haven't done any of that today, because just developing the whole plumbing was an incredible amount of work. But what we're trying to do now is also stabilize the fundamental architecture so we can start developing more applications. And once we stabilize that, my guess is it could be late summer, towards the end of summer. We will make this code open and available for people who want to try hack some apps together to kick the tires a bit. So stay tuned. Right now it is on a GitHub repository, but it's closed. But the intent is this will completely 100% be FreeBSD style or open source, which means that companies can take it, use it, and if they want to make money off of it, okay, fine. You have to talk to the University of Illinois and so forth. But you can certainly use it for free. Until NSF stops funding us, then you're screwed. No, just kidding.
We had some questions in the chat, but feel free to unmute and ask them in real time.
So maybe I can ask a question. So so you are comparing with Zoom and with other ways of collaborating, collaboration tools, and you know, the pandemic stuff in the last 1.5 years have given a big boost on collaboration tools. How much of Zoom do you intend to copy into your SAGE3, or do you try to do it all the way around, make SAGE3 actually a very cooperating citizen using the strengths of both systems? And one reason I ask it is this session is in Zoom, not in SAGE3. Right.
Well, yeah, I mean, once we release SAGE3, yeah, I don't see why we can't do this meeting in SAGE3. There are some issues with Zoom right now. We actually have started to look at that. Zoom does have an API that allows us to tap into it. But from our first cursory glance, the resolution of the videos that we're allowed to pull from it is very low. I mean, if SAGE3 does take off, you know, maybe Zoom might be interested in working with us. However, there are other platforms like Whereby that almost works in SAGE3. There's some login issues that you have to deal with, but we can actually see video directly in SAGE3. So basically, any video conferencing tool that can work primarily in the browser will just 99% run in SAGE3. So if you're familiar with Jitsi, Jitsi is like a free open source version of you know, Zoom, as it were, right? We should be able to run it within SAGE3. But we don't want to try and replicate all the work that folks at Zoom have done, because that's a lot of work and there's a strong user base in Zoom now. Instead, we want to do what we're really good at, which is content, right? Sharing content, sharing and manipulating content, allowing people to see more content and work with content. Yeah.
Who has the next question?
I still have a completely different question.
Go ahead, Case.
This was advertised as the combination of AI and SAGE, as it were. So there are two ways to use AI. You can either use AI to make SAGE3 smarter, but you can also use SAGE3 to get very easy access to entire toolboxes of AI.
Yes.
So AI for SAGE or SAGE for AI?
Both.
All for one and one for all.
Yes, so the grant proposal has targets to do both. One of them, like I mentioned maybe earlier on, once you have the wall full of content, it starts becoming really difficult for people to manage. And that's where AI would be helpful in doing that. And the other one is most scientists that we work with are just starting to dip their toes in AI, and they're not confident on how to use things. So we want SAGE3 to be the interface that allows them to just throw content up there, and the recommender system will say, oh, I see you have this type of data. This kind of analysis can help you get the answer, and it'll just automatically generate a chart, right? Because we can do a lot of preliminary AI type clustering and even, I mean, not even called AI, principal component analysis, that can help a scientist identify immediately what are the relevant parameters in the data set, plot them, because that's going to be their first step anyway, right? So we can remove that hurdle so they can start thinking about higher order analyses problems. Yeah. I don't know if Maddie is here by any chance, Maddie Belcade. So Maddie is the AI lead, and if he's here, he's here. Hey, Maddie, do you want to talk about that? Because you have this grand vision for AI for SAGE, so I want to give you a chance to talk about that.
Yeah, I think you've pretty much summed it up. But so the way we're seeing it is AI would be split into two major components. So the first component is AI to help the user be more productive when interacting with the wall, when using the wall, when using SAGE3. You can think, for instance, if you have two data sets, SAGE3 will be able to analyze the data sets and see if the data sets contain values that may be able to be used to merge the data sets. So you can think, for example, as of the first name, last name, or social security number, or student ID, or something like that. Or if you have, for example, 1,000 pictures and you want to organize those pictures in a meaningful way, so you can run AI to detect objects and cluster the data based on the similarity of the objects they contain. So you cluster the cats on one side and the dogs, and to give a very simple example. But also, we're making a framework, we're building a framework of AI that is run on custom hardware, so machines with large memory and GPUs. And the framework will make two things available. The first is a set of pre-trained models. So for example, if you want to do object detection in an image or a video, you don't have to train the model, you don't have to download the model, you only have to call an API. So this has two benefits. The first being you can easily integrate that functionality into new apps. If you're developing new apps, and the way we develop new apps right now is using React, you can easily implement that functionality using a very simple API call. You can call all the famous models, all the very sort of popular models, from object detection to text comprehension to maybe even video intelligence. There are a lot of models that we don't need to develop from scratch. The other part is building new models. So we're resorting to AutoML, automatic machine learning, and specifically a framework called AutoGluon. AutoGluon is a framework that allows you to stack complex models to build novel machine learning or deep learning models. And so both these approaches, the first one being the pre-trained models and the second one being able to call AutoGluon to generate new models, will be available. And these are hopefully the user won't need to write any code. It's just a matter of drag and drop on the wall, or customizing, tweaking some knobs on a graphical user interface.
And And I assume this will be very dependent on metadata that comes with the data. So it will also require metadata, because that's what you then need to work on, I guess.
Well, so yeah, that would be great if there is metadata. But in a lot of cases, so metadata for the training for the second part, if you want to do, for instance, build a novel model that does object detection of some object that we've never seen before. Let's say you're interested in finding cups, and we don't have a model for finding cups in images. Then you can provide metadata in order to train a model to find cups in images. But for the standard machine learning models that will be pre-trained, we can a lot of times just make the inference automatically. We can assume that, for example, you're uploading images. We know what you want. You can just click on a menu and automatically run up one of those models without providing any metadata.
Thanks.
I got a quick question. This is Brian with Stanford University. We used SAGE3 for a while, but we ran into massive memory limitations with the browsers. And with SAGE3, are you working with the browser companies to see if they will allow the memory issues to be scalable using SAGE3? So we can, because we mainly use, NVIDIA Index on servers that have thousands of GPUs to be able to do real-time manipulation of images. And the images are very, very big. So I was wondering if you guys have reached out to them to let us be able to increase that memory size to the browsers?
We haven't yet. We have experienced a lot of limitations with browsers, that period. And as a result of that, SAGE3 is basically an Electron app that runs on your laptop now. It's not a browser anymore because we've given up on that. And there's just too many changes going on in the browser place, and it's breaking SAGE2 left and right. The other thing we've also noticed is that companies like Zoom and Skype have started with some kind of a browser implementation of their video conferencing tool, but ultimately they also left the browser space to go into a native app. So it's weird. It's like the pendulum is swinging back to the native app space. But to address some of the issues that you're talking about, this is where it starts getting really interesting because, back in 2004, when the optoputer just started, we sort of envisioned this world where bandwidth is going to be cheap enough and abundant enough that we're going to have these servers that are going to be streaming pixels to our homes and you have these giant servers doing the computation for you, right? And it was a bit of a stretch back then because that infrastructure wasn't there. We were using gigabit networks and all this stuff, and the compression technologies weren't mature yet. Fast forward to today, where people have Disney Plus and Netflix, right? All of a sudden, it's starting to make sense that homes now finally have the network capacity and good compression tools to stream high quality pictures. So what you see in SAGE3, in some ways, is going back to SAGE1, where a lot of what you saw were actually pixels being pushed onto the individual walls. And so that's where we're going to have the opportunity to allow the powerful large-scale data processing and rendering you're talking about. We've already started playing with NVIDIA grid technologies. And also, I think Microsoft has a streaming to VR or headset kind of implementation going. This is for a separate project that we're doing for Army. So we're starting to evaluate some of those capabilities. I think that's how we're going to solve your problem, basically, Brian.
Okay, that's all wrapped up in SAGE3 is what you're saying, or are we looking at SAGE4?
No, we have to get it done in SAGE3. There are a host of other problems with browsers. I mean, when you go to a browser page because of all these ads, and you have Sage running on browsers across the wall, all the ads are different, and the interface becomes different. You have no control over it. But if we can run this in a server that streams the pixels out to you, then everybody's view is perfectly synchronized all the time. And it'll finally solve that problem that we were having in SAGE2.
So I have Jason, I have an application where I've got multiple classrooms. Each classroom has 3 4K screens, 3 large 4K screens. What kind of CPU, if it's all being done, actually GPU, I'd be more interested. I mean, can I get this, in SAGE2, when I did it, I had to have a whole bunch of NVIDIA cards in there to make it work, which wasn't practical. in a remote situation. But I mean, it sounds like this could be run on a single, NVIDIA 3000 series card.
Yeah.
And to that end, have you thought about leveraging some of the gaming platforms with their GPUs? The PlayStation 5, I assume you can get one, and the Xbox. I mean, those things can drive 8K.
They can. We haven't, just because it's always a pain working with the gaming companies because they like to close everything. And honestly, also, the gaming boxes are essentially souped up PCs.
Yeah.
And so we've primarily been using Alienwares. We like Alienwares. And then we'll throw in like a nice graphics card, like a 1080, 2080, 3080, right? And then they have 4 outputs, and all 4 can drive 4K, certainly enough for a lot of classroom situations. And that seems to be the hot setup these days. You go to Best Buy, buy yourself 4 82-inch TVs, each of them like
Well,
I saw it.
yeah, behind me, those are 6 4K displays running off of an Alienware with dual GPUs and dual GPU cards in there.
It's just, it really gated, the limitations gated by how many outputs people are putting on those graphics cards. We don't have control over that, but the software that we develop will expand across them, providing now that the operating system companies are paying attention to people putting big display walls together. That's another limitation that we discovered in SAGE 2. Microsoft decided, we're going to cap the resolution on our operating system.
Yeah. Okay. So I don't know anything. I don't need anything special in terms of GPUs. Just I need the outputs to make it work.
But I do want to say that we are moving away from driving these things with clusters. I know there are some large military type groups that have giant SAGE walls using clusters of computers. We're not supporting them anymore, frankly, because when we did a market survey, so to speak, of all the users, almost like 95% of the users have single PC installations driving multiple displays. It's the fastest, quickest, most economic way for people to get this capability. So we're focusing all our attention on that, because otherwise it's just too much work.
Yeah.
Both walls in Chicago and in Jason's lab are driven by single PC. What you see right now is driven by single PCs. And it's a situation of GPU outputs and stuff like that didn't change too much. But what we've seen a change is the controller to drive a big wall like this now are mostly accepting 4K link. So it gets a little bit easier to drive larger display from a single PC, because now we can take, for instance, 4K output and drive a relatively large wall from a single PC, and hopefully from a single video card. That's the best situation. Yeah.
So this is Leon here. Question about SAGE versus commercial applications like Bluescape. Is the scalable resolution some of the primary differences? And maybe you can talk about how this might be different from some of these commercial whiteboarding applications.
Yes, so it's very interesting that the space is getting crowded. This is great, because when we started doing this work, a decade ago, no one was in this space. And then now what we're seeing is that these companies like Bluescape and so forth are starting to catch up to what SAGE 2 was. And so that's where we differentiate ourselves. It's not that we are them, we are actually them plus artificial intelligence.
Plus open source free.
Plus, that's the price most scientists want their software at.
In scalability also, like at least a few years ago, a lot of solution where you had like that many SDI input, or you had like 3 Apple TVs and stuff like that. So here, hopefully we can scale into whatever hardware you provide and stuff like that. So from a single PC to a big installation. Maybe.
I see in the chat discussion of NDI and SMPTE 2110. I just would like to echo that having that kind of input, and so we're not dealing with standard stuff, but video over IP, either IPMX or 2110 or NDI, those would be really nice things to have. So I'm just adding to the chorus here.
Okay, we'll start a wish list.
And since also we didn't discuss a lot about the backend, but most of the components are containerized. It's what we're running now. It's a set of containers in the backend. So I think it would become easier for people to bring some application or some special functionality to offer into a container. So you might have a GPU accelerated container for ML or AI, or one for video capture and compression with NVIDIA encoders and stuff like that. So that's not, there is possibilities there, I think, and hopefully we still have more than 4 years on the grant to go. So
have you thought about adding audio capabilities, that even directional audio? So if somebody is moving their pointer around, their audio goes with them and they can talk and we can all hear each other, and having an audio chat going on in addition to the video?
We've done a little bit of that in SAGE3 when we had a big project with UCSD and so like that, where they had a microphone array and speaker arrays. And it's getting more commercial now. For instance, in this room, we're not using it right now, but we have microphone array in the ceilings and so like that. But for that stuff, so far we're using what's available commercially. We haven't looked at custom solution too much.
Yeah, but I mean, things like, for example, in the Sennheiser Team Connect's microphone system, which gives you XYZ positioning of whoever's in the data was in there. If you could link that to your pointers so we know when someone's speaking and the rest, and it would actually localize the audio. I'm doing a lot of work using those, and I've actually managed to hook up 6 of them together to cover a very large room, and it works extremely well, and they're not outrageously expensive. And if you want to be connected to those people, I'd be happy to do that. But it goes way beyond what the Shores and other people were doing. The stuff is really cool.
Yeah, we haven't used the Sennheiser mic arrays. We're mainly using the pucks, the Sennheiser pucks.
Yeah, the mic arrays, they've just recently released their newest version of it, and I've got that tied in with AI and camera control, and so they've got a room right now with 7 cameras being controlled by 3 of those Sennheiser microphones, and it's extraordinarily good.
Yeah, I mean, I'm very impressed with the Sennheiser stuff. The pucks are amazing for our conferencing uses, and you get exactly what you pay for. It's right, Sennheiser.
Yeah,
like good, really good.
And see, the video being driven by AI more and more. Even like Apple recently, now the camera will follow you. Even a fixed camera will crop and move around and stuff like that. So it's getting in your phone and everywhere. So I think we should be able to do similar stuff.
But just having the ability to, if you're people working in a room at a large wall, and you have your pointers moving around, if you attach the pointer to the audio, you could very easily get localized audio and stuff that Peter Otto was working on years ago. I mean, with directional audio, I mean, that's all very, very doable now without having to build out something. So I would encourage us to add audio to that capability. And do you have WebRTC functionality built into the JSON into your Electron app, so that we could actually embed video in there?
So we use WebRTC for the screen sharing.
Yeah,
but we could expand on that for webcams and stuff like that eventually.
Yeah, the WebRTC, there's some interesting activities going on with that, and open source and pretty high quality. And I would also encourage WebRTC. I would encourage, in addition to data sharing, audio and video sharing on it. I mean, don't try to copy Zoom, but if you have 6 or 7 people that are working together, why not have all that integrated with audio, video, and collaboration, and then take it one step further and do localization of where they are. Anyway, my 2 cents.
Your 2 cents is worth a lot, Greg. Thanks so much. And Jason, I wanted to pick up some of the other questions that are coming on the chat. I know that somebody else asked you already about security. I think it was Jeff, and you talked about authorization and encryption. When we've demonstrated SAGE2 in the past, people have said, oh, this would be great for medical visualization. and somebody on the chat pointed out that they'd need HIPAA, level confidentiality to be used in that application. Is that something that you might add to your wish list?
Yeah, security is definitely on the wish list. It's actually a little more than on the wish list. We wrote a paper that sort of outlines the kinds of security that SAGE type environments need, and what does it mean as far as the infrastructure that we have to build. Actually, what I didn't show you was that when you log into SAGE, there is a login screen where you can type in credentials. So we're working on that credentialing system right now. Maybe Luke can show it. But with that credentialing system includes things like permissions on what you can and cannot see and do within the SAGE environment. So yeah, it is definitely on our stack.
And then another question. I commented yesterday that you're fundamentally solved the requirement that we heard when we did the work in Hollywood, almost 10 years ago for, perfect mirroring, so people could rearrange on one board and have the other people see the exact layout for storyboarding or whatever. The other thing that people asked for 10 years ago when we were, showing it around SAGE3 was frame synchronization. They wanted people to be able to look at the same frame at the same time. And I know I asked the question yesterday, but now I'm going to turn it to Leon and George and Andy or Mats to talk about what tolerances of synchronization do we really need for critical viewing. Maybe Leon or Andy or George have a guideline for you how to think about that.
Plus or minus 0 frames.
Go ahead, somebody.
Yeah, Leon here, and then I'll let my colleagues talk. Obviously, it depends on the review applications. Certain applications, when you're just watching something, hopefully you stop on the same frame where you can see something. But if it's visual effects review, it needs to be critical on a frame-by-frame basis, of course. But just playing video, there can be some latency.
And what about audio video slip? How much
None.
does that need?
None. Sync, audio video sync.
You can easily see one frame.
So sync within a frame or sync to an audio sample? A lot harder.
Again, depends on the application. If it's a spotting session for sound effects, it has to be to the sample.
All right, there's a goal.
Yeah, so I would just pipe in on that. In terms of the design, I think it's always good for these audio visual applications to start from perfect sync, 0 latency, and high responsiveness. It's pretty much easy for anyone to just throw some pictures up and some sound and see where it lands. But to get it to that professional quality level, that always takes a lot of work. And then you can always add offsets plus or minus, afterwards. But I would focus the energies on getting for that lowest latency, 0 latency, and perfect sync.
Yeah, and there's another question that I had around calibration across multiple monitors. Are you using anything internal to SAGE or using external calibration tools to keep the wall calibrated?
So you're talking about color calibration and white point temperature and things like that, right?
Yes.
This is all external to SAGE.
So the displays would be calibrated. It's not a SAGE function.
Right.
Well, if I could pipe in, it might be. There might be profiles that through the SAGE control panel you might want to load and presets. In fact, there's a pretty good color management system I've heard of that might offer some insight. I'd like to do that.
Would that be an ace up your sleeve?
It is the aces out on the table, all 4 of them.
Let me put on my hat.
Yeah, so Jason and Luke, this is the Academy color encoding specification that Andy's been working on for a decade. Andy and his team, Andy and his colleagues. Well, Andy and Leon, any other questions for Jason and Luke before I remove your spotlight?
Remove.
Very good. Anybody else have something they want to add here to this discussion?
Yeah, I've got a comment. Michael Stauffer at the University of Pennsylvania. Myself, I'm a software developer, but the lab I work in is developing an auto ML tool as well. It's focused more on medical data, genomics, large big data sets. And it sounds a lot like what you're talking about in terms of helping researchers quickly go through a data set with recommenders that automatically make suggestions and then run through multiple different permutations, and you can look at quick results and all that. And I'm pretty sure my boss would be very interested to talk. If you're interested, I could put you in touch. And
absolutely.
Who should I reach out to?
You can reach out to me, and then Maddie will be also part of the conversation. So actually Maddie's closest background is in biomedical.
Okay.
Yeah.
All right.
So Michael, Jason, just to in the chat, would you please post some email addresses so people can reach you?
Yes.
And along those same lines, if people have, based upon what they've seen today, have suggestions or wish lists or requests, can they send that to you as well, Jason?
Sure, absolutely. Yeah, just send them to me, and I'll forward it to the whole group.
Very good.
And, actually, yeah.
Well, we still have a few minutes left. If anybody has additional suggestions or comments or questions.
Well, I just wanted to point out that we had a conversation yesterday about how complementary the SAGE3 approach to AI and a very thin client are to Nautilus, and all of the applications that we see running in Nautilus that do both, sort of workhorse ML tasks, but also very visual tasks running, and then just streaming pixels. You can have very, very powerful visual simulations running in Nautilus and then displayed locally. So I just wanted to mention that to folks, that's a topic that drew John Graham's attention, and I'm sure we'll see more of it in the future. I'm especially interested in that aspect.
Definitely.
Absolutely.
The other thing that we heard from John Graham yesterday was a question about running an Unreal Engine in a container on Nautilus and pumping that through SAGE3. Could you just talk to that a little bit, Jason?
Yeah, so the Unreal Engine is getting pretty popular for app development, giving Unity a run for its money, and also APIs for streaming out of Unreal into real-time headsets and things like that. We do have a project with Army right now that involves a remote rendering and streaming to everything from headsets to display walls. When we wrote that proposal 2-3 years ago, we kind of called it Netflix for scientific visualization, and they seem to like that idea. Their challenge is they've got all these different platforms, and they hate to port visualization tools across all of them. So they needed a unified way of doing things. So that's what we're trying to do for them. And a lot of this stuff where Unreal is able to stream out live renderings and also NVIDIA grids has, in a way, been a huge godsend, because we can leverage those services and not have to invent from scratch.
And any other questions?
Yeah, I might have one if I may step in. Miloš Liško from CESNET here. I was wondering actually how difficult would it be to display generic frame buffer using Electron. So I was wondering if we. Actually, I was thinking about doing what we did with UltraGrid and SAGE1 in a similar way with SAGE3. And it's been extremely difficult with SAGE2 at the same time to display a generic frame buffer using the SAGE2 infrastructure from UltraGrid. So my question was actually how difficult would it be using SAGE3 right now? The thing is that UltraGrid might actually bring stuff like NDI, which was discussed before, and a couple of other technologies into SAGE3 instantly.
And so Milos, you're talking about UltraGrid, right?
Yes, right.
Okay.
Luke, you want to take that?
Yeah, I think that falls into the overview, the bag of application that wants to send streams basically to SAGE3, and I think we're in better position now that there's the landscape of technology change in the last few years. So if it's, I think it would be similar if it could be NVIDIA Grid or an Unreal Engine or UltraGrid frame buffers. I think it falls into the same kind of technique, that there is a resource somewhere on the network that wants to send frames or video stream to SAGE3, and so we don't have a complete answer yet, but that's definitely something we want to look at carefully.
Yeah, we might do WebRTC as well, like almost instantly. Would not be that big pain, but generic, like generic frame buffer is going to be definitely beneficial, especially latency wise, I guess.
Right. And so there is nothing really to stop us. It's like we have to come up with maybe the right APIs or the right way to plug external sources into the framework.
Right. Yeah. Probably so. I was trying to find out if Electron has something like that already, but apparently, well, I was not able to find any usable API doing just 10 minutes of search.
Right.
So Milos and Luke, I'm sure you can follow up on these details.
Definitely, sir.
It's not like you don't already know each other. So thank you, Luke. Thank you, Milos.
Thank you, Luke.
And any other questions? We're getting close to our end of time. Well, if there are no other questions, somebody have another question?
I just want to have a comment, just congratulations on work and the progress that you've made.
Well, thank you, Leon. And thank you, Jason. Thank you, Luke. Thanks to the whole team. If we can, we're gonna.
Lauren, let's remind everybody that the access to the recorded sessions and to people's contact information will be available to all the participants and registrants coming from Jeff Weekly as a link after the workshop.
Very good. Thank you, Natalie.
Yeah, we did record both sessions. I'll probably do a little bit of a mashup, but those will be posted in the CineGrid Community Forum YouTube channel. That there will be a link to that in the follow-up email as well.
Very good.
This is really great. Just a good comment. Thank you. I'm excited, and Luke, I hope to see, and Jason, I hope to see the link to a beta, because I'm ready to try it out tomorrow.
Okay. That's what we're afraid of. Thank you for that, though.
And I'm just want to remind everybody that the CineGrid Community Forum summer calendar is next up is in July, on July 20th and 21st. We have the dive deep into AI and scientific visualization and computer architectures with the people from the National Center for Microscopy and Imaging Research at UC San Diego and the San Diego Supercomputing Center, Advancing Imaging Technology to Reveal Secrets Hiding in Plain Sight. And on August 10th and 11th, Alvy Ray Smith, who is co-founder of Pixar and a true pioneer of computer graphics, has authored a new book called The Biography of the Pixel. Becoming its public release is August 3rd, and will be one of the first groups to hear a presentation from Alvy about what he found when he dug into the ancestry of the pixel. And it should be quite interesting. He's a wonderful speaker. I want to thank everybody.
Registration for
Go ahead, Jeff.
Registration for both of those events is available now.
Right. So I just want to thank Jason and Luke once more, and I want to thank everybody for coming today. We had at one point 54 people on the call, and we hope that you'll, some of you will find it interesting enough to come back again next month.
And let's leave it open, Lauren, let's leave it open for a couple of minutes in case people want to stay on.
Absolutely. So we're right on schedule to end at 11:30, but we'll leave the Zoom session open as long as people want to chit chat. And I want to thank Jason and Luke and Maxine and Andy Johnson and Chris North and the whole team in Hawaii and in Chicago that's backing up this demo. Thank you all very much for attending, and the floor is open for free conversation.